So for this problem, for this problem, f happened to be 0, y0. So what's the y component plugged in? That would be a, the sine of t, 0, dotted with dr. dr is negative a, the sine of t, a, the cosine of t, dt. And that would be the integral from 0 to 2 pi of negative a squared, the sine squared of t dt. That would be negative a squared over 2, the integral from 0 to 2 pi of, this is 1 minus the cosine of 2t divided by 2, cosine of 2t dt, and that would be negative a squared over 2 times t minus the sine of 2t divided by 2, 0 to 2 pi, negative a squared over 2 times 2 pi, and if you plug that in, that's a 0 minus 0, so that is altogether negative pi a squared. If I look at if I use equation 3 to figure out circulations, well, look, I would say the integral along C of f dot t ds, that would be, I forgot to separate those and I should have used a different color. That would be the double integral over the region R of curl of f. They want it to be dotted with k. We're not going to worry about that because this is 2 dimensions. Like we said, dA, that's going to be the double integral. And let's see how that works. What is del crossed with f? Wouldn't that be partial with respect to x, partial with respect to y? Wouldn't that be y and 0? And that would be what? That would simply be 0 minus y minus 1. Partial with respect to y, that's a 1. Isn't that negative 1 dA? And hey, what's the area of that circle? Isn't that pi times a squared? Look at that. I don't even need to do any of that work. Isn't that awesome? And if I want to find flux, if I was to go ahead and do flux, if I take the integral along C of f dot n ds, or that's the closed integral along C of f crossed with dr, if you remember, that's the integral from 0 to 2 pi of f. F happens to be a y and a 0, and dr is dx dy. That would be the integral from 0 to 2 pi of, let's see what that is. Isn't that just y dy? And wouldn't that be the integral from 0 to 2 pi? And what is y in this case? Isn't y a, the sine of t? And what is dy? Isn't dy a, the cosine of t dt? And if I work this out, this turns out to be a squared, and if I let u equal sine of t, du is the cosine of t, so that's sine. That turns out to be u. So that's going to be sine squared over 2 of t evaluated from 0 to 2 pi. That's going to be a squared over 2 into 0 minus, that's just a 0. And if I use 4, and I'll say this integral of f dot n. And the only reason I could do both of those 3 and 4 because this is a closed interval over the region, the actual area of the divergence dotted with f. I'm sorry, divergence of f. Divergence of f. That would be the double integral. I'll get to that over that region. But what is the divergence? Isn't the divergence partial with respect to x, partial with respect to y? And isn't that dotted with y 0? And what would that be? Partial with respect to y. That's 0 plus 0 dA. Hey, isn't that just 0 and no need to do any of that work? So I could save myself tons of work. You'll be impressed by how easy this is going to be. Now we're going to go back to 16.2, whatever we did, and we're going to redo every problem using this shortcut. And you're not sure, do it the long way, and the only way you'd appreciate it if you look at 16.2 and look at the very last problem. Number 36, if you look at how we did that, if I just look at the area of this, I could run the area sideways, and I could just get that answer in no time. Anyways, let's look at some more problems. Okay, now looking at number 12, we don't have to verify anymore. It says use Green's theorem to find the circulation and the outwards flux. Well, circulation is really going to be the double integral over the region of del crossed with f, right, dA. And keep in mind what they're talking about here. They're talking about x equals 0 to x equal 1. And y equals 0 to y equal 1. If I was to do this using 16.2, I would have had to call this C1, C2, C3, and C4, and do this in 4 separate integrals. Now, all what I have to do is find that area of that region, and that's it. So what is del crossed with f? Let's get that out of the way. And that would be partial with respect to x, partial with respect to y, and there's f. That is x squared plus 4y and x plus y squared. That would be the partial with respect to x, the partial with respect to y. That's negative 3. Very good. So I know this is the integral of negative 3, and it doesn't really matter. I could say this is x equals 0 to x equal 1, and then y run from 0 to 1, and we know what that is. That's negative 3 times the area, which is negative 3. Instead of doing 4 separate integrals to find the work, and if I wanted to find the flux, again, instead of doing this over 4 integrals, all I'll do, I'll say, well, that's going to be the integral from 0 to 1, integrals from 0 to 1, and now I'm going to be looking at del dotted with f. So del dotted with f will be the partial with respect to x, the partial with respect to y, dotted with x squared plus 4y, and x plus y squared, and that would be the partial with respect to x, the partial with respect to y, that is 2 into x plus y. I'm going to go dx dy, and that would be, let's see, x squared over 2 plus xy, evaluates from 0 to 1 with respect to x, so that's 1/2 plus y. Integrate from 0 to 1 with respect to y, there's a 2 there, and that would be twice 1/2 y plus y squared over 2 evaluated from 0 to 1, and that's going to give me a 2 times 1/2 plus 1/2, what is that, 1? So I'm going to get a 2 altogether. And for you to really see what we just did, all what you have to do is go in there and do this the long way in one of those, and you'll see how that runs. I think I forgot to mention here, we went from x equals 0 to x equal 1. I forgot to talk about and y equals 0 to y equal 1. The rotation is counterclockwise. Otherwise, I have to put a minus in front of the circulation or flux. So I'm looking at problem number 26, which says find the work done by F by moving a particle in a counterclockwise, same idea, circle centered at 2, 2 with a radius of 2. There we go. We could use polar if needed. Let's see how this works. If we wanted to find work, we know work is the integral of C, and this is section 16.2. Yeah, I'm not going to stop. I'm going to keep on doing that. By Green's theorem, since this is closed, this is the double integral over this region R of del crossed with F dA. What is del crossed with F? Del crossed with F would be partial with respect to x, partial with respect to y, and 4x minus 2y. Come on. 4x minus 2y and 2x minus, you know what? I'm sick of this. Partial with respect to x, partial with respect to y, 4x minus 2y, and 2x minus 4y. There we go. What is that? That's a 2 minus a negative 2. So that's 4. And isn't that a circle? Wouldn't that mean that that's a 4 times the area of a circle? Radius 2, not 4. And there it is, done. What do you know? I don't have to say that x equal, that y equal, and come up with r and figure out what all of these are like we did. And the last problem I'm looking at, they say apply Green's theorem to evaluate the integral. In case you're not seeing what this is, again, I'm never going to stop. Isn't this 3y2x dotted with dx dy? Isn't that f dot dr? What is that called? Isn't that work again? And we know what that is. That is the double integral over this region. And let's see what the region look like. What's that region? We have x running from x equals 0 to x equal pi. And y runs from 0 to y equal the sine of x. They're talking about this region. Alright. Now, this is a negative rotation, right? So we're going to say this is negative, the double integral over this region R of what? Of del crossed with F dA. What is del crossed with F? Well, del crossed with F. Del is the partial with respect to x, the partial with respect to y. F is actually 3y and 2x. So what would that be? A 2 minus 3, which is negative 1. Negative 1 dA. That would be a positive the integral. And how am I going to do this? I'm going to run this from x equals 0 to pi. And I'm going to run y from 0 to the sine of x. And there's a 1 there. And that's pretty much it. So that is y times the sine of x evaluated. Oh boy. That is y evaluated from 0 to the sine of x. So that would be the sine of x. And I'm going to integrate that from 0 to pi with respect to x. That would be the cosine of x negative from 0 to pi. That would be negative, a negative 1 minus 1. That would be a 2 altogether. Yep, positive 2. Okay, and that's pretty much it. And there's your homework, page 1010, 1 through 17 on 25.